Hello, my name is Imran Aslam. Today I am going to give a demonstration on the gas turbine compressor application and explain the installation procedure of the application setup file. So let's look at the application installation procedure. If you have already downloaded the setup file from the website, then simply double click on the setup file. It will launch the installation setup wizard. From the language option, select the appropriate language and then press OK button. It will take you to the license agreement window. Here select the option for accepting the agreement and pressing the next button will take you to the information window. Again here press the next button, will take you to the option where it is asking to create a desktop shortcut of the application. It is always a good idea to create a desktop shortcut so that you can run the application straight away from your desktop. Then press the next button. It will take you to the final step of the installation. Here when you press the install button, the application will be installed on your computer in few seconds. Since I have already installed this application on my computer, I will just simply exit the setup installation wizard and go to my desktop where I have already saved the shortcut of the application. From the desktop shortcut, I will just double click on the application shortcut key. It will launch the application straight away on my computer. Now this application is basically designed to model, validate, revalidate or calculate for any given conditions or site based given conditions of the two-stage centrifugal gas compressor, which is driven by a gas turbine and also equipped with the HRSG, which is a heat recovery steam generator, through which you can generate the steam by using the exit flue gases from the gas turbine. Now let's look at the menu bar first on this application. On the left hand side on the file menu you will have three sub menus. The first one is the new menu, which actually used to launch the new instance of the application. For example, if I have closed this application, and I can simply launch the new instance of the application by simply pressing the new menu option here. Here you can see the new instance of the application is launched. Also there is a save menu under the file menu is provided to print out the results in the PDF format of the application, and the exit menu to close the application. The next is the about menu. When you press the about menu, you can read about the basic information of the application and the developer. Now the next menu is the help menu, which actually on pressing the help menu you can open up the application manual, which comes along with the application. So the manual is a good reference to read and look at all the detailed information regarding the input and the outputs and the results. So all the detailed narratives and with the pictorial graphics representation is provided in the manual. Now going back to the main application window, the next menu on the menu bar is the link to my website, where you can visit the website for more chemical engineering applications. Now coming to the main features of the application. This application contains various pages, as you can see from left to right: input variable, result page, schematics page, OEM data, etc., etc. So we will go through all these pages one by one, starting from the first input variable page, which will be launched at the first when you launch the application. Here in this input variable section, all the required information or the input variables needed to run the application are required to be filled in by the user. So here in the first section of the input field on the left hand side, user need to provide the physical properties of the gas at which the compressor is supposed to be running. Here the two set of information needs to be provided by the user. First of all, the user need to get the design information, design data of the gas properties, which the compressors were initially designed by the manufacturer. So this information can be readily available from the manufacturing or the vendor's manual or the data sheet, which you will provide it in the OEM first stage of the compressor, OEM second stage of the compressor. Similarly, user need to provide the gas properties for the side based first stage compressor, side based second stage compressor. Those are the information at which the compressor is running at the site on maybe different gas or a different composition and different physical properties. So here you need to provide both the information side by side in this input section. Next, the user need to provide the basic information like efficiency of the compressor. If it is available, then you can type in the value, or if it is not available, then you can simply check in this apply empirical equation check mark over here. In that way, the application will calculate the efficiency through an algorithm. So then you will provide the speed of the compressor at 100% load, which is again come from the operating manual or the vendor's manual for the best efficiency point or at the 100% load conditions. Once you provide this information, the remaining information on the centrifugal compressor speed for variable speeds ranging from anywhere from 80 to 110% or any value which you think the compressor is supposed to be running, you can change this numbers over here in the speed inputs, and then the corresponding speed in the RPMs will be calculated automatically by simply changing the number of the 100% speed load over here. For example, if I change this number to any number, then you can see the resulting speed in RPM corresponding to each percentage speed is changing or updated. So the user does not need to provide this information specifically. This will be calculated automatically by the application. Now moving forward to the next input section, which is the OEM first stage performance data at 100% speed. So basically at the 100% speed or the best efficiency point or the best operating point which is predicted by the manufacturer, the user have to get the information for the 5 basic set of information from the vendor's manual, which is the flow, polytropic head, pressure ratios, power and discharge temperature. Now for that one performance curve of 100% speed, user need to get this information from the vendor's manual, which is mostly provided along with the vendor's manufacturing data or the OEM manual. Now here the user need to get or provide 10 dataset values for each of these basic parameters in these respective fields in order to run the application efficiently and predict the site-based condition further on. As a minimum, if all the 10 data points are not available, then as a minimum 3 dataset values should be provided by the user in order to run the application for the best optimum results. Likewise, moving forward to the next input section, which is the similar information for the second stage performance data at 100% speed. Again, the similar information for 5 set of parameters needed to be provided by the user from the manufacturing data or the vendor's manual. Here, one important thing to discuss here is that most of the time the vendors simply provide as a minimum 2 set of information, which is basically either the flow and the head, polytropic head or the flow, whereas the remaining information like pressure ratio, power and the discharge temperature are not normally provided, or the curves or performance curves or the performance data for these 3 parameters are not provided by the vendor. Then in that case, the user, there is an option already built in the application that the user can simply tick this calculate check boxes for both the first stage and the second stage compressor, so that these three parameter values can be calculated or predicted by the application itself for the OEM performance data by using the inbuilt thermodynamic algorithms. Now moving forward, the next information section or input section is the input section for the gas turbine. Now since I have mentioned that these centrifugal compressors are driven by a gas turbine, therefore the user need to provide the information, design information from the vendor's manual regarding the gas turbine operating conditions. Similarly, user need to provide the HRSG operating conditions at which the HRSGs are likely to operate or will be operating at the site. Now the next section is the operating condition of the compressor. Now here in this section, user need to provide the operating flow rate of the compressor at which the compressor is supposed to be running at the site. Here the user can select the unit of measures for the flow, and the most basic and most common unit of measures of flow are already enlisted in the drop down list over here, which user can select appropriately. By selecting any of the units, then user can provide the information on the operating flow rate. Similarly, the user needs to provide the operating speed of the compressor at which the compressor is supposed to be running at the site, and likewise all the related other information regarding the first stage operating condition and the second stage operating condition of the compressor for the knockout drum, suction volume, suction pressure, etc. All this information need to be provided by the user in the respective fields over here. Once all this basic information or inputs are provided by the user, then the application is ready to run for the results. Once the application, all the inputs are available, user can simply press on this calculate button. Once I press the calculate button, the calculations will be done. Once the calculations are completed, the message bar below will turn into green background color with the title OK on it, which means that the calculations are done, are completed without any errors. No error messages are found. Later I will explain all the results that are calculated by this section. But let's, for example, if at any point the user has provided any incorrect input value. For example, the user has typed in accidentally a text value in the input field where the numeric data should go. Then by pressing the calculate button, the application will stop running, and instead it will display an error message in the message bar saying that there is something incorrect inputs have been provided. So the user has to go back to the respective field and revise the information, come back to the calculate button, press the calculate button again, and then calculation will refresh and results will be produced afterward. Now that's all about the input pages or the input information. Let's move to the next pages on the application. The first page after the input variable is the result page. Once you click on the result page, the result section will be shown on the application, where all the results which are calculated by the application are displayed over here. So let's look at the first section, which is the compressor results. On the compressor results section, the calculations have been done for the first stage and the second stage of the compressor for both the operating conditions, which is the site-based conditions, and the OEM provided information or the design data of the compressor. You can review all this information for the first stage and the second stage of the compressor. Similarly, for the HRSGs, the results are calculated for the production of the steam, boiler duty, and all other important parameters are displayed over here in the fields. Also, in the warning section, if there is any warning predicted in the application, that will be displayed in the descriptive form in the warning section over here. Similarly, for the air compressor, suction side information or the calculations are done and displayed in the respective field, and the compressor discharge side, air compressor discharge side for are displayed over here in this section. Similarly, for the gas turbine, inlet conditions are calculated and the gas turbine outlet conditions are calculated in this section. Now moving forward to the next tab, which is the schematic here. This is the simple layout or the schematic of the entire package, showing the gas compressor, showing the air compressor and the gas turbine, which are governed and run by under the Brayton cycle. And then this gas turbine is connected with the first and second stage of the compressor, and the compressor has further components of first stage knockout drum, aftercooler, and the second stage knockout drum and the aftercooler. And below is the HRSG, which is a boiler showing how much steam is producing from this HRSG. And all the important information are also populated on the schematic at different streams, just to take a quick look at the application. Now moving forward to the next section, which is the OEM first stage performance data. Now here the performance curves are predicted and calculated by the application for all the governing variable speeds that are provided earlier in the input section, and the results, calculated results, are shown in the tabulated form or tables in this section. So again, this is for the first stage OEM data, performance data, that is populated here. Similarly, the second stage OEM performance data of the second stage compressor for all the speed from lowest to the maximum speed are shown here. Also, the performance data of the surge curve and the stone wall curve are also calculated and projected in the tables over here. Likewise, for the side base conditions, the performance data for the first stage of the compressor and the second stage of the compressor are also calculated and display accordingly in each of the respective tabs. Now at the last, the performance curve tab, this tab actually shows the graphical representation of all the process performance curves, compressor performance curves, for variable for various process parameters, like power curves for the OEM first stage performance curves, OEM second stage, side base first stage compressor, and the side base second stage compressor. Similarly, you can view the head curves, discharge pressure curves, discharge temperature curves, and pressure ratio curves. So for all these 5 important parameters of the compressor, the performance curves for each of the parameters are displayed and projected in the graphical manner in the performance curve data tab over here. Now once all this information, once you have reviewed all this information and you are ready to print out the results, to print the results you can simply press the print preview button. Then the print preview window will be launched and you can review the printed result on the paper, which can be saved further as a PDF file or print out through in a hard copy through a printer. Here you can review all the results. There are total 39 pages. Report is generated by the application, which comprise of all the input data and the result sections, including the graphs and the tabulated data. All the information which are just shown on the application are projected and displayed in the print screen, in the print format. Now exiting the print preview format, now once the data is ready and you wanted to take the print of the results, you can simply press the print button over here. Then a print dialog box will open where you can either print the results in the PDF format or straight through the connected printer, the hard copies of the print you can get it. So now looking at the results section, after when I print the copies of these results, here how it looks like. Once you print out the results in the PDF format, the PDF format will look like exactly as it is shown in the print preview tab. There are total 39 page report will be generated by the application and can be saved as a PDF file later on to use through email or etc. Now moving back to the main application. So here are the pretty much all the information and explanation about the main feature of the application has been explained. Further, the reference manual is a great help to look at the details of each step and the explanation how to provide the input and vary the inputs accordingly while running the application. Hope you have liked the video. For more informative videos on my chemical engineering applications, please like and subscribe my channel and visit my website. For now, thank you very much. Bye bye.